In this video, we're going to be talking about logarithms. Now, logarithm is closely related and associated with indices, okay? So if you really want to understand logarithm, you must first at least know how to tackle problems on indices as to make it easier for you to understand it. Now, similar to indices, there are also what we call the laws of logarithm, and it is important that you learn these laws in order for you to be able to tackle problems and solve questions that are based on logarithms. Okay, so first things first, we're going to be dealing with the laws of logarithms. Okay, now there is no fixed number of laws that we have in logarithms, just like indices. There is just a few, and from there we combine two or more to get other laws. Okay, that's what we're going to be doing. So if you've not watched our video on indices, I advise you might want to watch those videos first to understand indices before you can come and then learn logarithm. Okay, now unlike indices, remember if we're having a to the power of m, the m here is the exponent or power, and the a here is the base. But in logarithm, if we're having, for example, log a base b, a on top becomes the power and b here becomes the base. That is what it means. Okay, so for indices and logarithm, we consider two different numbers as the power or the base in general. Okay, now we're going to start with the law 1, the first law. Law 1. Now for law 1 on our list, unlike indices, we'll be multiplying, we're going to be adding. So we're going to have, for example, if we have log a base b plus log c base b, what do you notice? We're having two logs of numbers, okay, and then they are adding each other. What you notice is that they are having the same base. Okay, the numbers are having the same base. Because they're having the same base, we can pick one, log to the base of b, and then for addition we are going to multiply the powers. So that is a times c. So you see it is similar to indices. For indices, multiplying, same base, we pick one, and then what now, add the powers. For logarithm, adding, same base, we pick one, and then what now, multiply the powers. Okay, that is the trick to solving these problems. Okay, now for law 2, we're just going to replace this plus with a minus. So that's going to give us log a base b minus log c base b. Now this is going to give us log a divided by c, and the base will be what now, b. What is the reason? They are subtracting each other. They are both logarithms, they're having the same base. So we're going to pick one, and then we're going to what now, divide the power. Now remember, we are going to divide the first one by the second one. Don't go and divide c by a. So this is going to be a divided by c, not c divided by a. Why? Because a is coming first, that is a is before the negative, so a should also come out now first. That is how it is being done. Now let's talk about the law 3. Okay, for law 3, here's what we're having. We're having log a base b, not just log a base b, the a here is carrying a power of c. Now whenever we are having the log of a number such that the power of the logarithm is having its own power, okay, remember this is the power, this is the base. But if the power of the logarithm is having its own power, that power can come to the back of the logarithm as a numerator. So we can bring this c to the back of the logarithm as what now, a numerator. Hence we are going to have c log a base b. Now watch, for law 4, what if we're having log a base b, and in this case it is the base that is having the power. Initially the power of the log was carrying the power, but this one, the base of the log will be carrying the power. Now in this case, the power of the base can come to the back, okay, but when it comes to the back, it will come to the back as a denominator. Now since it is coming as a denominator, it means we are going to be having 1 over c log a base b. It is that easy. For the first one, it goes to the back as a numerator, giving us c log a base b. For the second one, it comes to the back as a denominator, giving us what now, 1 over c log a base b. Now your mind should tell you that if I'm joining law 3 and law 4 together, I'll get a new law. Now what will that law become? If I should call it law 5, it means if I having, for example, log a raised to power c base b raised to power d, the c comes to the back as the numerator, d comes to the back as the denominator, then we are now going to have C over D log A base B. That is how we are going to do it. Okay, so you've seen that we've now combined log 3 and log 4 to give us what now? Log 5. Remember I said as we go on, some of these laws are actually combinations of one or two or more of the laws we're already having. Okay, so it is that easy. Now let's talk about law 6. For law 6, it is similar to something we did on indices, okay, but let's assume some of you haven't watched that video. I'm going to explain to a point that will make sure you guys actually get what we're talking about. Okay, so if for example we're having log A base B is equal to log C base B, notice something. On both sides of this equation we're having log to the base of B, which is common. So since they are the same, log to the base of B, they can both cancel out, and then we're left with A is equal to C. This means that A is going to equal what now? C. Okay, that's what the law means. Now let's talk about law 7. Okay, for law 7 we are going to be combining some of these laws. Okay, here law 7 is saying that if we're having log of A base B, it is equal to 1 divided by, we can now switch these two numbers to give us log of B base A. Okay, that's what it means. So if we're having log A base B, we can switch the two numbers on top, but we're going to take the reciprocal. That is 1 divided by log of B base A. Okay, now let's now take law 8. Now this law 8 gives us the relationship between indices and logarithm. There are sometimes we'll be given a term or an expression or an equation in form of indices, and we'll be required to convert it into logarithm for us to solve it, or logarithm will be required to convert it into indices for us to solve it. Okay, now here is the relationship. If for example we're having A raised to power X is equal to B, this one is indices. To convert this guy into logarithm, what was going to happen? This A rather, is going to be raised to everything on the right hand side or everything on the left hand side if this one was here and this one was here. Okay, this base here, A, is going to be raised to B, which means if it is raised to B, we are going to be left what on the left hand side? X. And immediately we raise it to the power, we're going to bring it what now? Log. So this now becomes log B base what now? A. Okay, that's what is happening. Or we can simply say, to make it easier for understanding, we can simply rewrite it as, okay, we can simply rewrite it as, if we're having log A base B is equal to X, this B can be raised to this power and the log disappears. Hence, we're now left with A is equal to B to the power of X. Notice how the logarithm disappears and we have now converted it into a form in terms of what now? Indices. Now this is the relationship between indices and logarithm. Okay, now most persons or most books you find to apply this law, what they do to these indices is they take log of both sides. By the time we take log of both sides, we're going to be having log A base what? A, and then we're going to be having log B base A. So log A base A is 1 and the likes. That is how it is being done. Okay, we're going to get there. Now let's talk about law 9. Okay, let's talk about law 9. Now for law 9, here is what we're going to be having. If we're having log A base A, okay, if we're having log A base A, take note, whenever we take the log of a number such that the number we are taking is same as the base, okay, our answer is always equal to 1. Okay, whenever we take the log of a number such that the base and the power are the same, our answer is always equal to 1. So if I may ask, log 2 base 2 is equal to what now? 1. Log 3 base 3 is equal to 1. Log 4 base 4 is equal to what now? 1, and so on and so forth. Log 0.5 base 0.5 is equal to 1. Okay, as far as the base and the powers are the same, our answer is simply equal to 1. Now how about log 10? Okay, for log 10, what then are we going to be having? Okay, what are we going to be having in law 10? Let's say we are having log A base B times log B base C. Okay, now whenever we are multiplying two logarithms, there is something you should check. Whenever we are multiplying two logarithms, check if the base of one of the log is same as the exponent of the other one. If the base of one of the logarithm is same as the exponent of the other one, they can both cancel out, and we are going to be left with log of the exponent that is remaining and the base that is remaining. Here's what we're having. Okay, log the exponent that is remaining and the base that is remaining. So log A base B times log B base A. Since B and B, they are the same, that is the base here is same as the exponents here, or it could be the base here same as the exponents here. They will both cancel out, and we're left with log A base what now? C. Now here's another one. Let's take log 11. Now for log 11, if we're having a whole number, okay, or a number raised to the power of a log, let's say we're having a to the power of log B base A. Notice that the base here and the base of the logarithm, they are the same. Okay, notice they are the same. Whenever we're having a situation like this, now we can just say A will cancel out A, and our answer is simply equal to 1. Here is the proof. Now if we are saying a to the power of log B base A is to be simplified, how then are we going to do it? Now to do this, we are going to say, okay, let the whole power be equal to x. So log B base A is equal to x. So we're going to say let it be equal to x. Okay, then we're going to apply this law, the relationship between logarithm and indices. So if we convert this into indices form, we're going to get B is equal to A to the power of x, right? But then we said let x be what? Log B base A. So we're going to have B is equal to A to the power x is what? Log B base A. So you see A to the power of log B base A is what now? A, which means A to the power of log B base A is what now? B. Rather, A to the power of log B base A is B, which means A to the power of log B base A is what now? B. Now come here, A to the power of log B base A is what now? B. Okay, so it means what we're having here is equal to B. These two guys can cancel out, and we're left with what now? The exponent. So A to the power of log B base A is equal to what now? B. Now we can only do this if there is no number at the back of the log. Please take note that if there is a number at the back of the log, we must first take it back to the power. Let's say there's a 2 here. We cannot just come and cancel both and then leave our answer as 2b. No. We are going to first take this guy to the power, giving us b squared. A cannot cancel a. We are now left with what now? B squared. Please take note, that is how problems like this are being tackled. Okay. Now the last one we're going to talk about is called the change of base. Oftentimes, especially in exams like in the WAEC, okay, they give you questions to solve without scientific calculators on logarithm, and they expect you to do them. Okay. Now when you use a normal calculator that is non-scientific, when you take the log of a number, it takes the log of that number to the base of 10. So if I should go to my calculator and I press log 5, it means the log is calculated is log 5 base 10, even without you putting a base. Okay, that is what all calculators are designed to do, non-scientific calculator. But what if we are to find that log 5 to base of 2 or base of 3, but there is no way to do it? How then are we going to do it? We are going to apply the law of change of base in logarithm. Okay, now how do we do that? So we're going to call that law 12. Okay, we're going to call it the change of base. Okay, now to apply a change of base, we can simply make use of the rule we are having here. Let's say we're having log A base B, log A base B. Okay, to apply the change of base, we are going to bring in a new arbitrary base. Let's say we are bringing in a new base x, okay, or a new base C. To put in that new base, here is how we are going to rewrite this log. Okay, so this now becomes log our normal exponent A and our new base C divided by log our initial base B and our new base what now? C. Now you notice that if I choose to cross multiply for me, I'm going to get what is here, which is exactly the same thing I was having here. Watch, log A base B times log B base C. Log A base B times log B base C equals log A base C, which means we're actually on the right track. So it's either we know this one and from them we derive this, or we know this and from here we derive this. So they go what now? Hand in hand. That is why I said from one law you can get the other, or from one or two more laws we combine it to get others. Now also take note that whenever you are given ln of a number, let's say ln A in terms of logarithm, it simply means the log of A to the base of exponential. Okay, to the base of exponential. You should know what it means. It is Euler's number. Okay, that is what it means. So if you are seeing log to the base of e, it simply means ln a, or if you are seeing ln a, it simply means log a to the base of e. Now we're going to be solving problems as usual. Okay, we're going to be solving a few questions as usual, so make sure you have a good understanding on these laws that we have on the board. We're going to be applying these laws in solving those problems now. Okay, we're going to be solving these problems on the board. There are 7 questions here on logarithm, and then there are JAMB questions from each year. Now you can see the first one is JAMB 1999, 2003, 2008, 2021, and okay, those ones the years were attached, and these ones they don't have years, but still they are JAMB questions. Now the first question is, if log to the base of 8 is equal to x, evaluate log 5 to the base of 8 in terms of x. I'm going to come here and then I'll write solution. Okay, the question says, now it is written in terms of it is written in words. Okay, so if log 10 to the base of 8, which is log 10 to the base of 8, that's what it means. Okay, is equal to x, so it is equal to x. We are now asked to evaluate log 5 to base 8 in terms of x. Now we are now asked to find log 5 to base 8 in terms of what now? X. Okay, now to do that, so we might want to break this one down. Okay, to break this one down, we're going to write it in such a way that there will be 5 and 8 included in it. So 10 is the same thing as 5 times 2, so I can write it as log 5 times 2 base what? 8. Now applying the laws of logarithm, this can be broken into log 5 base 8 plus log 2 base 8. Okay, what we are looking for is log 5 base 8, so I want to make it the subject. So if I make this the subject, I'll have log 5 base 8 is equal to, what is here is log 5 times 2 is 10, so you have 10 base 8 minus, bring this one to this side, we have log 2 base 8, right? Now log 10 base 8 was given the question as x, so you have x minus log 2 base 8, but we're not just going to write log 2 base 8, so we're going to simplify it. 8 is the same thing as 2 to the power of 3, so we can write it as log 2 base 2 to the power of 3. Remember from the law of logarithm, we said that when there is a base here or a base carrying a power, it can come to the back as a denominator. So we're going to be left with x minus 1 over 3 log 2 base 2, of which log of the same base and power is equal to 1. So everything here is equal to 1. 1 times 1 over 3 will give you 1 over 3, which means our answer is x minus 1 over 3. Very, very easy. Doesn't take time to solve. By applying the laws, we are going to get our answer straight up. Okay, that's for question 1. Now question 2 says, evaluate log 4 base root 2 plus log 16 base 1 over 2 minus log 32 base 4. Okay, that's what question 2 is saying. So for question 2, we have to evaluate log 1 over 2 base x, or rather question 2, which is log 4 base root 2 plus log 16 base 1 over 2 minus log 32 base 4. Okay, now to do this, first thing you might want to do is make all the bases the same. Now we can do this by picking a common base and multiplying where needed and dividing where needed, or we can choose to simplify each of them and then add and subtract our final answers, whichever one makes it easy. But first things first, I want to make sure all our bases are the same, okay, and they are equal to 2. So I can write this as log 4 base 2 raised to power half. Remember, square root is 1 over 2, okay, in power. We've done this in indices, so if you don't understand this part, you might want to go and watch our video on indices, okay, plus log 16 base 1 over 2, same thing as 2 to the power of minus 1, okay, minus log 32 base 2 squared. Now all these powers can come to the back as what now? Denominators. So if this one comes to the back, we are going to have 1 divided by 1 over 2 log 4 base 2 plus, okay, this minus 1 comes to the back, so we have plus 1 over minus 1 log 16 base 2 minus 1 over 2 log 32 base 2, right? Now let's simplify the numbers in back. 1 over 1 over 2 is 2, so we're going to have 2 log 4 base 2 Plus times minus is minus, so you have minus log, since it's 1 there, so don't need to write in the 1, 16 base 2, minus 1 over 2 log 32 base 2. Now we're having the same base, common basis, okay? What we can do is we can pick one base, one common base, that is log 2. But we cannot do that when there are numbers at the back. We have to take them to the powers first, okay? If we take them to the power, we're going to have log 4 squared, because this one comes to the power, okay? Remember the law says if we're having the power, it can go to the back. The same thing means it can also come back, okay? It can be reversed. So you have 2 minus log 16 base 2. There is no number here, that is why it's left like that. Minus this 1 over 2 goes to the top, so you have log 32 raised to the power 1 over 2 base 2, okay? That's what it means. Now we can now pick one, okay? We're going to have log to the base of 2 in brackets 4 squared divided by 16 divided by 32 1 over 2, okay? Now 4 squared is already 16, and 16 divided by 16 is 1, so it means we are going to be left with log to the base of 2 of 1 divided by 32 raised to the power 1 over 2, okay? And this can be written as log 1 divided by 32 raised to the power 1 over 2 is 1 over 32 raised to the power 1 over 2 base 2. Okay, for indices, what we're having here can go to the top. Since it's a fraction, we're going to have log 32 raised to the power minus half base 2. Now, there's a power here again, it can come to the back. So we're going to have minus half log 32 base 2. Now, to break down log 32 base 2, we have to simplify it in such a way that 32 will be having 2 inside of it. This is to avoid using the calculator, okay? How then are we going to break it down? Now, we do know that 32 is 8 times 4, right? 32 is 8 times 4, okay? 8 times 2 is 16. We want to do it in such a way that we're going to be having 2 inside of it. So what we might want to do, we're going to use the simplest approach to questions like this, okay? We know that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So notice 1, 2, 3, 4, 5. 32 is 2 to the power of 5, right? So we can replace 32 as 2 to the power of 5. Now this now becomes minus 1 over 2 log 2 to the power of 5 base 2. Okay, 5 can also come to the back as a numerator. We're going to have minus 5 over 2 when this one comes to the back. Okay, log 2 base 2. Now log 2 base 2 is 1. 1 times minus 5 over 2 gives you minus 5 over 2. And that is the answer. So that is how a problem like this is being tackled in the JAMB exam. Okay, by solving multiple exercises, you get used to it, and then it will be easier for you to tackle more problems. We are going to be solving the next question on the board. Now the next question, question 3, says if log half base x is equal to 3, find the value of x. Okay, question 3 says if log 1 over 2 base x is equal to 3. Let's find the value of x. Now to do this, the method that comes to my mind first of all is the change of base, or not even the change of base, but the relationship between indices and logarithm rather. Okay, because when I explain that, you notice that we'll have something like this. All you have to do is use this guy to raise whatever is on the right hand side, and then we'll be left with half, which means we can have 1 over 2, which is half, is equal to x. This guy is going to raise be raised to the power of 3, okay, raised to the power 3. And now we want to what now? Solve for x. Okay, to solve for x, we can just take the cube roots of both sides. So take the cube roots of both sides. Cube roots can cancel out TV, so I'm left with x is equal to the cube root of 1 over 2, which can be further simplified to 1 over the cube root of 2. Okay, I'm going to write it boldly. 1 over the cube root of 2. That is how it is being done, because cube root of 1 is 1. So I left with what now? 1 on top divided by what now? The cube root of 2. Okay, number 3 was quite easy and straightforward. That was from JAMB 2008. I think that was a bonus problem. Now for question 4, simplify 2 log 2 over 5 minus log 72 over 125 plus log 9. Now you notice that in this particular problem, there is no base given. Now if you are giving questions where there are no base given, I will tell you two things. It's either you assume a base or you solve with it like that. Now I'm going to show you how I'm going to solve with it like that. So I'm going to solve this problem assuming there is no base, okay? And since there is no base, it means they are having a common base. Since all of them, they are not having anything, okay? Now remember, We want to pick a single log since they are not having the same, but we cannot do that because of these 2 in front of here. We must first bring this back to this point before you can now pick it. Okay, so we're going to take this one here on that part of the board. So for question 4, I'm going to do it directly. We're going to take the 2 to this top. That becomes log 2 over 5 all squared. Okay, that's what we did. Minus log 72 over 125 plus log 9. Okay, applying the laws of logarithm, minus, which means we are going to divide these 2 powers, plus, which means we are going to multiply by 9. So we are going to have a single log in brackets 2 over 5 all squared divided by 72 over 125 times 9. Now, how then are we going to simplify this? We're going to have log in brackets 2 squared is 4, so we're going to have 4 over 25, of which 5 squared is 25. Okay, this 125 is going to come to the top, so it's going to multiply 125 divided by what will be left in the bottom, 72 times 9. Okay, what can we break down from here? 25 into 5, 25 is 1. 25 into 125 is 5, right? What else can we divide? Now 9 can go into 72, that should be 8 times. So 9 here is 1. 9 into 72 is 8. Okay, 9 into 72 is 8. 4 here is 2, or 4 here is 1 rather, and 4 here is 2. So we're left with log 5 over 2. So our final answer becomes log 5 over 2, okay, without a base, just like the question that is being given. So that is how a problem like this is being tackled. Also easy. Okay, now the next question, I did not write it here. It says evaluate log 8 root 2 to the base of 2. Okay, so the question says we should evaluate log 8 root 2 to the base of 2. How then are we going to do that? Remember, 8 root 2 is something as 8 times 2, so we can write it as log 8 times root 2 base 2. Applying the laws of logarithm, law 1, we can split this. So we're going to have log 8 base 2 plus log root 2 base 2. Okay, now log 8 is 8 is 2 to the power of 3, so we can write it as log 2 to the power of 3 base 2 plus log square root of 2 is 2 raised to the power half base 2. This one can come to the back as a numerator. This one can come to the back as a numerator. We're going to have 3 log 2 base 2 plus half log. This half comes to the back, okay? Half log 2 base 2. Now log 2 base 2 is 1. Log 2 base 2 is 1. So we're going to be left with 3 times in brackets 1 plus 1 over 2 in brackets 1. 1 multiplies all this, gives it the same. So we have 3 plus half. Now 3 plus half is simply what now? 3 and a half, right? Or we can simply make use of the normal math. That's going to give you an LCM of 2, 6 plus 1. Okay, that's 7 over 2, which is something as 3 and a half. Okay, that's simply the math. Okay, so that is how a problem like that is being done, and the answer is 3 and a half. Now the last question on our list, we have to solve log 6 minus x. Log 6 minus x, okay, for question 7, we have to find x if log 6 minus x and the base of the log is 2 is equal to 3 minus log x base 2. Now we can solve this in different ways using different approach. We can choose to bring this one to this place so I can pick one common base. That's one method. I can choose also write this in such a way that it will be having a common base with that, but I feel that will be longer, so I might want to bring this one to the other side. So I'm going to have what is on the left hand side, 6 minus x base 2 for a log, okay, plus, by taking this one to this side, we're going to have log x base 2 is equal to 3. Yeah, and then there's a common base here. We're going to pick it. Log 6 is a plus, we're going to multiply this, so x times 6 minus x, so I have x times 6 minus x, okay, base 2 is equal to 3. This one picks this one, so I'm left with x in brackets 6 minus x is equal to 2 to the power of 3, right? Remember the law of logarithm I gave you? Okay, conversion of indices. If you're having a log and a number here, we can convert it to indices, and the base of the log is going to be raised to what is on the other side. Okay, so x times 6 is 6x minus x times x is x squared equals 2 to the power of 3 is 8. Now we're having a quadratic equation which we are going to solve. We can as well rearrange it, take everything to the other side. We're going to have x squared minus 6x plus 8 is equal to 0. Now, how are we going to solve this quadratic equation? Let's be sure that our equation is correct. Take this on to the other side. Get x squared minus x plus 8. Okay, now let's see if factorization method is going to work. Okay, let's see if factorization method works for this particular quadratic equation. What are the factors of 8? There is a here is 1, so it means we're going to look for the factors of 8. What are the factors of 8? The factors of 8 are in fact 1, 2, 4, 8. Okay, which of these are we going to multiply or add to get which of these are we going to multiply to get 8 and we're going to add to get 6? Yeah, I think 2 and 4 is going to work. 2 times 4 is 8, but how do we add it to get? Okay, let's try minus 2 and minus 4. Minus 2 times minus 4 is 8, and minus 2 plus minus 4 is minus 6. Okay, the shortcut of doing this, we're just going to divide by this and then reverse the sign. Okay, but I'm just going to do it directly. So this means we're going to be having x squared, okay, minus 2x minus 4x plus 8 equals 0. Yeah, so from here we're going to factorize x in brackets x minus 2. Okay, then over here we're going to factorize that minus 4 in brackets x minus 2 equals 0. So we have x minus 4 times x minus 2 is equal to 0, which means from here x minus 4 equals 0 or x minus 2 equals 0, which means x is equal to 4 or x is equal to 2. Now the possible answers to our questions is x is equal to 4 or x is equal to 2. Okay, you see, this one led into a quadratic equation. Now if you've not solved or learned how to solve problems on quadratic equations, you might want to watch our video on quadratic equation as well. Okay, it is still on our YouTube channel. Now if you did learn something and you might want to help us create more videos for you, smash the like button, and if you have a question, leave it in the comment section. Okay, don't forget to turn on the notification bell so that when new video is being uploaded, you'll be one of the first person that will get notified about it. Okay, help yourselves and help your friends by sharing the video to them as well. See you in the next video. Bye.